evaluation. So I'd like to start with the historical reference of sorts. So I have I don't know if you can see, I have the first edition of Advanced R with Hadley's autograph, and there are no chapters on evaluation. There's no chapter on quasi-quotation. There's a chapter on non-standard evaluation. So it looks like Hadley wrote that chapter, cursed a bunch of times, like I'm cursing every time I had to read it in the first edition. That this is those are those are bad design decisions. Let's let's try to improve that. So they've rewritten Erlang and invented a bunch of language along with that. I don't think quasi quotation uh, is does have a meaning outside of R. Um, and evaluation probably has slightly different meaning in other languages and other environments. So that's it. So today we're gonna learn evaluation basics. We're gonna learn about closures, which is another made-up word uh, for the topic. Data masks, and we'll try to understand tidy evaluation. So we um we are in the meta programming section of the book. So we are talking about um how to deal with language components and how to operate with abstract elements of what the user is supplying in their functions on if their function calls of what we need to exchange between the different functions ourselves in our code. Um, so Hadley says that there's a distinction between unquotation, which gives the user the ability to evaluate parts of the quoted argument. We've seen bangs where you can say, well, this is an expression, but I only want to figure out what bang is referring to within that expression. And evaluation is our developers tool to look at the expression as a whole and see, okay, well, in the set of existing environments, um, where do we need to resolve ambiguities as necessary? John made the reference to Lisp. That's, yep. Yep. That is, I stand corrected. That quasi-quotation comes from Lisp, and I think I'm gonna try to insult Lisp. So Lisp stands for lots of silly parentheses. So the computation that is parenthesis, parenthesis, parenthesis. Uh, Everything is parenthesis. I've done a tiny bit of that, where in year 1990, where I was doing some sort of engineering graphics, engineering design, and we used some Lisp-based systems, whatever they were 35 years ago. Okay, so and base R started with the concept of non-standard evaluation. So I think here's a reference to Thomas Lumley's kind of note, white paper of sorts on that um, in the R consortium space. And he talks about all the pains of working with that. R was there in 2003. R was probably version 1.6 or something like that. And basically, you start with match call and you force some stuff inside that matched call. You replace the name of the function inside that match call. This is severe hacking. So Erlang makes it kind of more modular, somewhat more elegant. And as I said, the non-standard evaluation was one of the chapters in the first edition of the book. Um, and so this is, well, while that stuff obviously still works because it based on this somewhat more elegant uh, way of dealing with the problem using the tidy evaluation tools. Um, so the base R is providing eval, EVL, uh, to evaluate, run, execute expressions. So sometimes you're going to use this as an assignment. Sometimes you're going to use it for, I don't know, side effects. I don't know, you're knitting something, knitting a markdown document, or you're printing something out. So that might be a way to use eval just as well. Um, so in my code, there is a mixture of both. So if you don't state inside eval which X and Y you are referring to, uh, R will try to figure out uh, what's happening in the current caller environment and try to find X and Y in there. But you can specify the environment as an explicit argument and say, well, this is my environment where X is 1,000 and Y is 10. And then, of course, that evaluates to 1,010. Um, so Hadley talks about the imaginary application of re-implementing source. Um, so what source does is well, in plain language, it runs a R script. In more complicated formal language, it read lines all the code, um, parses the expressions in that code, um, and kind of I think to think here is whether those expressions need to be quoted or they should stand as expressions. Evaluate each expression, return the result. So what source does, I didn't know that, but it returns the result of the last expression. So and so we read lines from the source .r file. We parse expressions, and there's some a little bit of simplification here is that this is a list of no, this is not a list. So read lines returns a list of lines, and then everything is pasted with return end of line symbols, and that whole conglomerate is getting parsed with this parse expression. Then everything is attempted to be evaluated, uh, and the last result is invisibly returned. So you're basically saying, well, if there are syntax errors in any of those expressions, eval is going to stumble upon them, and we don't really have to care that much. So also source has the ability to echo output, echo the expressions that are appearing here, copy the results to copy the objects that are created, the environment that's created along the way, the environment inside this source function uh, into the caller environment and so on. So the real source is much more complex in that regard. So what are the non-standard evaluation bits and pieces here? What is the stuff that we're quoting? So um, here we are starting with this uh, really long character. Um, and this is expressions are getting parsed out of that, and those expressions are getting evaluated by eval. So inside we have this list of expressions. So one of the not exactly weaknesses, but sort of well, sort of design You can improve a little bit on design of eval by saying, well, what if I wanted to do this in a pipe? So you want to do everything in a pipe. So how do you pipe into eval? Well, you need to have a singular object rather than a pair of expression and environment. And closure is exactly that idea. It says, well, let's create something that has an expression field and has the environment. So this is called closure because it's quoting the expression and it's enclosing the environment. Um, so the baby step is just to say, well, I have a new closure. So my expression is expression x plus y, and my environment is environment x equals 1, y equals 10. In more practical way, uh, Erlang provides enquo for a single enclosure or enclose for a list of enclosures, for a list of closures. And what this does is it's creates a closure that contains the expression. So here we're saying foo, a plus b becomes x, x gets quoted, becomes the expression a plus b, and the environment slot of that object is, in this case, simply global environment. Um, and there is something that exists for some sort of completeness reasons, and Hadley said, don't bother using those quo and closures. It's kind of, they intended to work similar to expressions, XPR. So once we have a closure, we can pass it into eval ID. So that's where I said, well, if we want to have a singular closure that combines both expression and the environment in which it needs to be evaluated, um, you can pass this to eval ID to compute on that. So what was Q1? Let's remind ourselves. So Q1 came here. Yes, this was the environment, the closure that has x plus y in the simple environment where x was 1 and y was 10. So you can get a call for that environment. It just says, well, the environment actually exists. It's distinct from the global environment. And here's the memory address for that, if you care to look at it. And there's probably a way to print that. Print that all. So in your work, you might find yourself, well, I need to recycle the expression, but I need to set a different environment. In this case, you can set environment or set expression. Those are lang functions to do that. This is the name of an existing closure, and you can feed the new environment and evaluates to 7. Remember, the expression was x plus y. So dots. So um dots is often a ticking bomb, right? You, as the function developer, kind of relying on users to be reasonable and pass dots that are meaningful. But when you're operating within your own functions, of course, you have full control over that. So one particular problem is that you may have multiple entries in dots, and different entries may be originating in different environments. So, and this little piece is starting a little abstract for me, so I had to go several times through this chunk of code to figure out what's happening. So, uh, so this function is just creating enclosures of its inputs. And create closures is sending the input dots into G, and appends what? Appends not a closure with f equals x. So and here's all of this was to demonstrate that you can have in this case the closures that are created. So one is global equals x. Nothing is evaluated here, but it's just created here. That this is the name of the environment is called global. This is expression x in that environment, and that's those dots that were passed all the way through. But also at this stage, and create closures also supplied f equals x. So f was the name of the closure, and x was the expression in that closure, and it has its own environment. We don't know if x exists in that environment. Well, x does exist in this environment of create closures. So if when we come to evaluate that, we're gonna evaluate that to 1, and this one is gonna be evaluated to 0. So kind of going back in the history lane, the predecessors of closures were formulas. So formulas was a special type of thing in base R. Well, they still are. They still operate that way, where you can capture some sort of a syntax, some sort of an expression, and some sort of environment. So now that I've read this thing, I now understand a little better why I have some stored objects that were 10 gigabytes in size when the only thing I needed from them was like 50 megabytes in size. This was some random trees that I was working with or something like that. I now see that the package, whichever package it was, I don't remember by now. This random forest, the random tree package that I was using must have saved the formulas, and formulas may have dragged the whole global environment with it. So, and that is potentially bad for me because I work with restricted and sensitive data, and this behavior is not kosher. I don't want that to be happening if I'm working on that sort of data. I only want my objects to contain the stuff that I want them to contain. So, um, so this is all to say that formulas still work that way. So there's a language component uh, as the kind of front and center of that, and there's also attribute environment that defines that. And closures actually have to inherit that. So that's um, closures are still formulas, although they probably I haven't tried it parsing those as formulas, but it's just the way this stuff is set up uh, in this and in other our workflows. So I think there was a graphing language in like about 10 years ago, lattices, I think, right? Uh, I don't know if it still exists and is under development, but that was a formula-based graphical engine in R. I think it was just running the base graphics in much smarter ways, using formulas where you would say, okay, well, this is what I want to put in my graphics, and this is the environment, is the data set that they need to be taken from. So this is a historical reference, so that you could tie this with the code that you see in all the packages. They would use formulas, not as in the sense like linear models, um, like y tilde x1 plus x2, but it's also a way of storing syntax along with environments. Is it possible to inadvertently bring a global environment if you create a formula or use environment caller interactively? Well, probably, likely, possibly. Uh, as I said, when I was using at object size on that crap that I was dealing with, it was showing those 50 megabytes. But when I was loading, but the our memory usage was going up in increments of 10 gigabytes. And that was probably the size of the global environment that they were created in. Mm-hmm. Thank you, John. Yep. That's exactly that. Yep.
The butcher package exists like specifically to deal with that problem, and it's wrapped into all the tidy model stuff.
Awesome. All right. So what John dropped in the chat uh, is the is the example of that. So more, in all likelihood, random forest is what I was working with, and there should be library random forest on top, but um,
Yeah, I took
that's
a subset.
all right. So that is the function that has this habit of just dragging everything with it, and um, yeah, his code shows that it's taken 10 megabytes, where the reasonable need for that is only for 400 kilobytes. Yep, that's that is an example of a package that passes CRAN checks, but is not the greatest package, um, because the developers were not particularly um, friendly towards their users in the ways. Um, so formulas, closures. Okay, next. Nested closures. So uh, it was advertised that there would be different colors, but I don't see different colors here, frankly. Maybe if you try this in a better um, environment, maybe that's gonna show here. So here we are supposed to try to figure out, okay, well, what if you do dirty trick and say, I have a closure with X in it, I have another closure with X in it. What if I'm trying to add those two X's? Well, that gets evaluated. That gets evaluated to 101 as we would expect, but what is the underlying expression? So the underlying expression was supposed to be like red X plus green X. If you run this in your uh, RStudio and positron, that is supposed to show up with different colors to just draw your attention to the fact that those are different axes. And here this rendering print is tried to do that in some different way, and I don't think it was successful with that. Okay. Any questions so far before we move on to the data mask as a concept? Okay, data mask is a specific type of closure where the environment that you're working with is a data frame. So the symbols are attempted to be interpreted as column names in that data frame. So that's how dplyr operates, that's how ggplot operates, right? So when you write mutate, you don't need to specify data $, or whatever, and likewise in ggplot, so you just provide the names of the column names for the variables that you want to work with. So and here they kind of return to the eval with two arguments and saying, well, this is where we had the expression, but now I've changed my mind, and well, I want to have a second argument to eval tidy, which is the data frame to evaluate this on, and this is wise from 1 to 10 times 100, 100, 200, 300, and so on. So know that in this environment, in Q1, there is no y. Expression exists kind of a little bit of a limbo until y is provided, and that y comes from the data frame. And so this is this expression is evaluated with data mask of this data frame. I think that's the formal language to call things that way. Okay, so exercise example, implementing the width function. That's I use it occasionally, and I'm typically scared of it because I'm not understanding this. So this is quotas are from local environment are colorized according to their environments. If you have crayon installed. So this is this was
Yeah,
supposed
I
this
suspect that's why.
Crayon is little historical, right? So CLI is the more
It
modern version of that.
CLI uses Crayon, I think. So in theory, it should be installed, but it's possible it's optional. It might be like in suggests for just about everything. Actually, I think it might be. So we'll try.
Okay. Okay. Are my slides going to be re-rendered?
Not what
Then
it'll take a little bit, so
okay, yeah,
don't wait.
That's a
no
question.
problem.
So it seems like a data mask is just evaluation, but you're calling it a data mask when the data is a data frame. No,
That
but if you go to an environment, it's not a data mask. Is that right?
well, I don't really know if there is a kind of specific set of functions or methods that really saying, oh, you're giving me some random environment, not a real data mask, right? So I think one of the assumptions that are happening with data masks is that all of the symbols you can evaluate are going to be the same length, right? Because they arose in the data frame. So if you have an environment where X is C23 and Y is C456, that may work as a data mask, but then you start recycling arguments. So X becomes 232, and other problems will probably start appearing. So uh, I think data mask is just a language that they use for the I mean in both the advanced R and in the tidyverse documentation, tidy select, tidy R, dplyr, rlang, just to say, well, this is a closure, but it's the closure of a special structure. And that structure is that of a data frame. So, and so with function, with two function. So the way with function works is you supply the data frame and you supply the expression to be evaluated on that data frame. And that's basically just two lines of code here. Is first you enclosing that expression, and when that enclosure happens, the environment is the caller environment, but when you run eval tidy, you supply the data as the environment for that expression to be evaluated. Martin says, I like to think that data mask means that you are prioritizing the evaluation in the data frame rather than an environment. Well, so this is like, if you remember old days of Twitter, before it was called text, there was an account called Why Does R? Raise your hand if you remember that in reactions. And all that, when you add, thank you, Ella. When you add that account, it sends back a random New York cartoon with the caption for compatibility with S. So S called their objects, their environments frames, and then it became data frames when environment only contains the data, and data frame is a valid context of an environment. That said, this also gives limitations, right? So when you want to compute something within the existing environment is like as if it were isolated from anything else, you cannot grab anything from outside world, right? Maybe you can grab the value of constant pi because it's somewhere very deeply in the guts of R. But if you have x equals 10 outside in your global environment and you're operating within the data frame as an environment like in those quarters, then you don't see that x. And your mutates, if you're thinking, okay, well, do this mutate only within the data frame? It's gonna say, I don't know what you mean by X. So in that sense, data frame is a valid environment, and that's terminology that's used for that. Is just you used to we all used to environment having a cable. There's a bunch of text constants, there's a couple of data frames, there's a ggplot object hanging in my global environment, and all of that stuff. This kind of kitchen sink of everything. And data frame is just a very regularly structured environment. That's how I think about that. Okay, so this is with two lines of code. Actual with is of course far more complicated. And here's your non-standard evaluation with base R. So it relies on substitute, which is mentioned the first line somewhere in Thomas Lumley's text. And then the base evaluation of expression and data, and if there's anything else needs to be found, then that has to be taken from the core environment. So yeah, so that's the kind of base implementation of that re-implementation of that idea. So so you say with df assign, this should be an assignment, assign y from x. Do you mean x as common df? Is it something in the outer environment? Where should x come from? So that's in that regard, if you're working with data mask, it will be prioritize thinking about x as a column in df, but otherwise functions like this would have to figure out and John is feeling something with crayons and the background. So ambiguity is maybe that's you meant X from the data frame, maybe you meant X from the environment, maybe you have some nested environments with different sort of X's in them. And R has to figure out what do you mean by that. And DevTools check and ArcCMD check is insisting on those things to be very clearly defined. If you expect that DF has X, you need to specify that. If you need that X has to come from an external environment, your function should probably take that as an input. So, and DevTools check gives warnings and complaints about no visible global bindings. It basically means, you remember 2-3 classes back, we talked about abstract syntax trees, ASTs. So it went through those ASTs, resolved other things, but for that X did not appear anywhere on that syntax tree, and DevTools is pretending to be confused about that. So here's our competing ideas here. So we create a new closure with an expression of x times y plus x, and we put this into environment with x equals 1. So we supply data frame where y is 1 from 1 from 5 and x is 10. And when eval tidy gets evaluated, we see that priority, as Martin was saying, thinking about data frame, data mask, priority is given to x within that data frame. But maybe you meant this x, maybe you meant that x. So there's a way to prioritize that. And there are ways to express that with the Erlang pronouns dot data and dot env, dot environment. So you can say specifically, okay, let us disambiguate that I want X, even though it's not declared, I want X to come from this, from the data. I know what the data looks like, and that's the stuff I do now in my project code where my functions operate with data frames of no structure. I put the data just to be super safe. Alternatively, you can say X means X must come from the environments, the nearest environment where you can find X. And so here you can say, well, take this X from the data and take this X from the environment. And X was 10 in the data frame and Y was 1 to 5. So this evaluates to 10, 20, 30, 40, 50. And this evaluates to +1. And that's how you can override the priorities for evaluation with data versus environment. Okay, so subset. There's a base function subset that works like deploy filter. It selects rows of data, rows of data frame based on expression. So to re-implement subset, we would expect that to receive a filtering expression. So within that code, within our function, we need to figure out which rows of data frame are needed, and we subset return the data frame. So that's what base subset does. That's what deploy filter does. That's what data table operating on the first rows argument does. So that is something that's a common operation, and we need to understand how that works. So rows argument is going to contain our filter expression. So the first thing we do is we encode them, convert this to quoted argument. Then we say, let's evaluate this on rows of data. And I added a little bit of a protection here. So I think Hadley's only had is logical rows value, and I added that the length must be the same. And we return the result. So show of hands if you remember what drop equals false for. Nobody remembers?
Oh yeah, make
Nick
sure
remembers.
make sure it's a data frame and not like if you only had like one column.
Right. So that was one of the annoyances of base R. If you end up subsetting a data frame to a single column, then it becomes a vector. And likewise, if you subset this to a single, I don't know if you subset this to a single row, it becomes a vector or not, but it might. So and drop equals false is basically saying do not drop the class of the resulting object, retain the data frame class of that. That's my interpretation of drop equals false. Okay, so here's our sample data frame, 1 to 5, 5 to 1, and some mixture of those. So we are subsetting for B equals C, so that's going to match 5. The first position, that's going to match 1. In the last position, so that's the subset. So and here's attempts to break it. If you supply something that is not a subsetting condition, you're supposed to get an error out of this. So in this case, this eval tidy picked up 42 here. 42 is an expression, 42 is an expression, rows val evaluated to 42, but it did not evaluate the logical condition, so the error was tripped here. So we supplied true, just to return everything. And likewise, it's was quoted here to true. It evaluated, ideally evaluated to true, and then but length of that row's value is not equal to rows of data, and it was stripped here. But other than that, this is the main case. And while John is at that, maybe you can find a way, John, to have row names have colors as well. Just very visual thinking. Looking at the chat. Okay. So one functionality of subset is you can select specific columns. So here we are selecting columns from B to D out of A, B, C, D, E. So B, C, D is 2, 3, 4. How John, I think there's something that was dropping from the compiled slides. I had more text in there because well this was supposed to be to say what do we need to get out of this? What's the core bit of that select is being able to figure out well how to go from the list of from the vector of from this select expression expression that is given by the user to the vector of logical true false corresponding to which columns of the data frame need to be retained. And that functionality is this is in creating this list of variable. Basically, this is a lookup table of variable A is column A is the first column B is the second column, and so on. And then when that lookup table is created, this is this is computed on those columns to create indices of the columns that need to be processed. So let's trace this B through D expression through this function. So comes here as dots, right? It gets converted to enclosures, and we say this is enclosures in plural in case we have something like A, comma, D, colon E to select kind of different windows. So this is this lookup table is created here on the list mapping the variable names to the column numbers. Then the dots are tidily evaluated on this within the environment of that list, right? So and basically this is saying when you see B, return number 2, when you see C, return number 3, when you see A, return number 1. Didn't happen because this B through D did not have A, but it ended up with columns 2 to 4, and this was subset and returned implicitly returned in the last section. So this is what select does in this simple way and shape. And tidy select dplyr helpers is just a rich set of functions like starts with, end with, contains, matches, all of those that help you operate on the logical expressions at roughly this step of evaluating those regular expressions to be mapped to columns. Okay, so we're going to be dealing with a lot of eval tidy in our developers workflows. So Hadley argues that we may not actually use eval tidy that often, but there's going to be we're going to be calling functions that use eval tidy all the time. So use case. So this is a resample with subsetting. So this is the first draft of the resample function. So we take a data frame, we take the number of rows that needs to be resampled that with replacement, and this is the set of indices that are getting created, and you return data frame with those indices, and it looks like the first observation was selected 3 times, the second observation was selected 3 times, then the first observation was selected again, and so on. So what if we wanted to provide a subset argument to this function? If we only need to sample a portion of that data set, and do this in the simple step. So if we put this condition as the input to this function, then it fails. So what happened?
time
So,
to evaluate it? Like,
well, where was this evaluated? So this was evaluated in the color environment of in the environment of this subsample, and there is no object B inside that environment. It should have been evaluated in the DF environment, and that did not happen at the runtime. So there some stuff should have been quoted. I think this is the same bit of code. Yeah, so this is the explanation. The color environment does not have B and C. And sometimes, well, you could even fool this function to have B and C in the color environment, and B equals C is not going to evaluate to subsetting condition because they are of different length. So the appropriate solution to that is to unquote the condition and bang it when you pass it to subset so that it's retained in the expression form rather than gets evaluated whatever that B equals C may be in the color environment. Instead, it should be passed as with understanding that this happens within the data frame. And if you remember that B equals C, it was row 1 and row 5. This is row 1, this is row 5, and one of those rows get repeated because we are resampling with replacement. So I kind of think that the moral of this story, of this explanation, is that when you expect to be dealing with expressions, the first thing you do is you export them or unquote them, depending on the context of what you're doing. This prevents this condition from those input parameters from being evaluated in the color environment. R will not gonna look for them in the color environment. It's gonna look for them in the environment then you specify them for. So here's the next twist on that is if you were to try to threshold based on X and you code it sloppily, you say, well, subset X greater or equal than value. Well, where does X come from? Where does val come from? So you need to disambiguate that and say, so X, I think of X as the known name of a column in my data, but this val should come from the environment. And in this case, the environment is of this function. So, and what this will do is it will force evaluation of the value argument when this call to subset 2 is formed. So if you said threshold X df comma 5, then that 5 is going to be computed, and this is what's going to be pasted into subset 2. So and this is thresholding on steroids. So there's an expression to be thresholded, and there's the value to be thresholded on, and you quote the expression, and in this case, the value is getting banged. This is the first time it appears in this whole scenario, so it's getting passed as the symbol and evaluated as a symbol. So this is the comment. Kind of it's going back a little bit to the earlier discussion that Martin kind of brought up, that the data mask, where the data mask is prioritizing certain calculations or is it self-contained. So one limitation is that the data mask may not have everything you need. So in the kind of very worst case, if you're unable to bring appropriate functions to that, that's going to break even with simple calculations. So Hadley said that as a general rule of thumb, as a function author, it's your responsibility to avoid ambiguity with any expressions that you create. It is the user's responsibility to avoid ambiguity in expressions that they create. So once again, this is what I mentioned a few slides ago, that DevTools check finds those ambiguous symbols and notifies you of those. So if you build packages, that's a very helpful reminder. And it's a segue to packages second edition, if it's ever offered again. I took it last year. It was tremendously useful. So users can do whatever stuff, but as a function author, you need to think when you write stuff that is not fully defined within a function, where that stuff may be coming from. So I have like 1 minute left. There's kind of down the history lane, there's a base evaluation with substitute and match call, which leads to things like this, which is not helpful. You used to seeing LM formula Y MPG on displacement and data equals empty cars. That's what you would have wanted to see. And here this is LM does this match call, and it does not do all of the things that tidy evaluation does. And this is the fix for that is to process formula and data separately from the call, print the call with expression print, and then evaluate that, and then that shows up properly. So again, this is kind of how to work with some of the historical packages, and the LAM is probably 35 years old by now. It's one of the base R things. And I think this is my last slide. I'm at time. I'm
All
sorry
right.
you didn't have room for questions.
No problem. I believe someone has signed up for next week, but I have to run over to my other meeting, so I'll check that out on Slack. But thank you. That was great.